Okay, yesterday we did linear regressions. Now there's 3 other types of regressions you're going to have to know how to use in your calculator. That's the log regression, the exponential regression, and the power regression. I do have the linear there showing just to compare it. And we're looking at the different things. The linear regression, since it represents a straight line, it would be linear. Look at the next one though, the log regression. That's not a straight line, so it's definitely not linear. However, it looks like a normal log function, okay? It increases pretty quickly and then it slows down. An exponential will slowly increase and then increase very, very quickly. So those are your examples of exponential. And for power, very similar to exponential. The difference, it is allowed to go through the point 0, 0. So exponential does not go through 0, 0. So I was going to put no 0, 0 here. The power goes through 0, 0. So yes, your point will go through the point 0, 0. And logarithmic, it will not go through, so no 0, 0. And your y-intercept will, for a log regression. Sorry, log regression. So it does not go through 0, 0. And what you do have to remember is that the x is also greater than 0, meaning you are never going to go on the left-hand side of the y-axis, while the other exponential and power, you will. Alright, so I'm going to do 2 problems with you and you'll do the third on your own. A mail order company has shipping boxes that have square bases and heights from 1 to 5. The relationship between the height and the volume is shown in the table. Determine which regression model is most appropriate for the data. So yesterday I told you, use linear. You type them in your calculator, into stat, you hit your stat edit, and you chose number 4, which was your linear regression. This one doesn't say which one to use, so we have to decide. And our choices are linear, exponential, power, and log. Log I'm going to abbreviate LN instead of LOG. The way we determine which one is best is we look at the R values. Okay, so take a second, type them in your calculator. I'll give you some time there. Stat edit, clear out your list, type the height into list 1. And type your volume into list 2. Check over your numbers, make sure you typed them correctly. If you need to, pause the video at this point to finish, but I am going to move on. You will hit stat, you will hit arrow over to calc, and let's choose number 4 first, which is our linear regression. And if we look at it, it gives us an R value. I'm going to use 4 decimal places, 0.9459. So that's pretty good. Let's see if we can beat it. So we're going to hit stat, arrow over to calc, and we're going to choose, let's do our exponential next, which is choice 0 in your calculator. And that gives you an R value of 0.9750. For the power regression, you hit stat, arrow over to calc. Power is choice A. And it gives you an R value of 0.9999. And for the log regression, just be careful with this one. The log regression is choice 9, not choice B. B is logistic, not log. So choice 9 is your log regression, the LN. That R value is 0.8557. Based on this, we can see the best R value is the power. So we have to go back to the power regression. So it's going to be stat calc, number A or letter A, and it wants us to come up. It says which is most appropriate and justify. So we will say power. Sorry, we'll finish this question because R is closest to 1. Now it says come up with the equation. So now in your calculator you should have your power regression up. It says we're rounding to 3 decimal places. So it's going to be y equals 2.024. Then it says times x, so times x to the b power, so to the 2.991. And that's it. That's your equation. Moving on. In an office building, the thermostats have 6 settings. The table below shows the temperature Fahrenheit for each month produced. Use a power model. So this one tells us what to do. So hit Stat and Edit, clear out your lists, and type your new lists in. If you need to, at this point, pause the video so you can finish typing in, but I am going to move on. You're going to hit Stat, you're going to arrow over to Calc, and you're going to choose the power regression, which is letter A again. We will write the power model. I'm going to write it in the first question. I am going to round to 4 decimal places because it didn't say. So it's going to be y equals 60.8114 times x to the 0.0760. What temperature will result from a setting halfway between 2 and 3? Notice the setting is the first list you typed in, so it's the x. So you're going to type 60.8114 times 2.5 to the 0.0760. Type that in your calculator, and you end up getting 65.2 about degrees Fahrenheit. Finally, where should the setting be placed to produce a temperature of 68 degrees? What we are going to do, oh, I'm going to need to erase that line. It's not going to let me. Okay. What we need to do is plug A68 in for the y. So it's going to be 68 equals 60.8114 times x to the 0.0760. To solve for x, we're going to start by dividing by the 60.8114. So we have x to the power equals, I'm just going to leave it like that because it's not pretty. Now to get rid of that power, 2 ways. We can use logarithms, which everybody hates, or we could take the reciprocal power. The reciprocal of 0.0760 is 1 over 0.0760. Please type carefully in your calculator. You end up getting x equals about 4.35. At this point, you guys can try the do now problem.